Hi everyone, my name's Nicole.
Hey, I'm Ben, and this is our business stats project. We're going to be going over the Case-Shiller Index, and a couple of the cities we're going to be looking at are going to be Boston, Dallas, and Seattle. We're going to be going over a couple of the different factors that actually change this index to make it go up, go down, see what seasonal adjustment is, and look at some other statistics.
So the S&P Case-Shiller Index is a compounding table of single-family home prices. So this is used to study home pricing trends over time. So we started in January 2000. That's when it first started being compiled. And we went through the last available date, which was August 2015. So we used these to see whether home prices increase or decrease over time. At January 2000, when it started, the index number was normalized at 100 in order to compare whether they go up or down. An identical index number, even if they're years apart, indicate that the home prices were the same at those times.
Next, we're going to talk about seasonal adjustment. What seasonal adjustment is when outside variables come into a statistic and cause inaccuracies and issues with the data. One of the issues we have here with seasonal adjustment is something such as seasonal jobs, or for example in this case, with unemployment would be like a crop season. What crop season does is it's going to cause the unemployment rate to go down quite a bit because there's a huge influx in jobs, when realistically once we come out of that season, unemployment rate will rise again as the jobs go away. So one way you can keep accurate data would be to always apply seasonal adjustment so you don't have these huge fluctuations in your index. Next, we're going to talk about the Case-Shiller graph we have here that shows the 3 different cities.
Yes, so this is the graphing of all of the indexes. The bottom one he's pointing at is Dallas, and then Seattle, and then Boston is that top blue one. So both Seattle and Boston, they peak a lot more than Dallas does, and we found that this was the U.S. housing bubble. So the housing prices were inflated a lot more than they should have, and which led to the peak and then that downfall that follows. And Dallas did not have that. And so this also led to the 2007 recession.
Next, we're going to talk about the mean indexes of the 3 cities. The highest of the 3 is going to be Boston at 156, Seattle at 145, and then Dallas at 120. It seems a little bit odd being that Seattle peaked at the highest, although Boston's mean is the highest. That happened because Boston, although it did not peak as high as Seattle, it held a higher point for a longer period of time, and when the housing bubble crashed, although it did go down as well, it didn't go down quite as bad as Seattle did. Dallas, being the more average of the 3, didn't have a high peak or trough during the bubble that crashed in 2007, although it never really got above 130 for a consistent period of time. Next, we're going to talk about the standard deviation of the 3 cities.
Yeah, so the standard deviation is just how much the points vary from the mean. And so a higher deviation just means that it is not as close to the mean as the other smaller numbers. So Boston had about 19, and Dallas was the lowest at about 10, and Seattle was about 26. And so it was pretty easy to understand that Dallas would have the lowest because it doesn't have that high peak that we keep talking about. It stays about the same. I mean, it varies a little bit. Obviously, that's why there is some deviation, but it still isn't as high as the other 2. We also looked at the ranges, mostly of Seattle.
The range of Seattle is 92.3. The way we come up with that is you look at the initial value, which is 100, and you look at the peak in July of 2007, which is 192, the difference being 92.3. One reason you may want to look at the range versus the starting and ending point would be the starting and ending point leaves out a lot of data. You would see 100 and you'd see 184. You'd never see the peak of 192 during that, right before the bubble crashed.
All right, next we made a histogram. In this case, we used it for Boston. Here it is. On the x-axis, we have our class intervals, 100, 120, 140, 160, 180. And then on the y-axis here, we have the frequencies in which they occurred during this time, the class intervals. And so you can see here that these 2 have the highest frequency by a lot. This was when, on that graph that we saw, there was that peak and then went down a little bit, but it's still in between those class intervals. These were high because a lot of people were buying homes at this time, and this actually led to a lot of homes being underwater.
Part of the reason this happened was when the housing prices were high, a lot of people thought they could sell these houses they could buy them, wait for them to rise a little more, and sell them again. Well, when they realized the housing prices weren't going up, and the fact that the value of their houses were below their loans, everyone tried to sell, causing the housing prices to dip even more and more and more, allowing everyone else who previously bought homes were then also underwater. What being underwater in your mortgage actually means is where the loan left on the house is worth more than the house itself. So even if you were to sell your house entirely, you would still owe more money to the bank. This is what caused the 2007 recession, and it was a big reason of the housing bubble burst.